Welcome back, geography students. It's Mr. Eddie here. Today's lesson is going to be on the acronym low or near water. Specifically, we're going to be looking at elevation and how elevation has an effect on climate. Also, we're going to be looking at how to do the elevation calculation, okay? So some things you're going to need to actually complete this lesson is a pencil or a pen, a piece of paper, and definitely a calculator, and definitely your mind. Okay, so let's get started. Okay, so as we get started, I think it's really important for me just to go through the low or near water acronym once more. Just prior to this, I actually made a video on the low or near water acronym, and we went through all the effects of climate based on the low or near water acronym. We started off with the L, so the L stands for latitude, the O, ocean currents, the W, wind and air masses, the E, elevation, the R, relief, and then lastly, near water or proximity to water. So each of these 6 things has a distinct effect on climate, and I just want you guys to know that before we get started. Okay, now what I'd like you guys to do is you're going to write down the 5 pieces of vital information that you're going to need to complete the calculation. The first is going to be the sea level temperature. Okay, the second is going to be the condensation point. Height. The third is going to be the peak height of whatever elevation that you're looking for. And then you're going to need the 2 cooling rates. So the cooling rate to the condensation point. And lastly, the cooling rate from the condensation point to the peak. Now, for the sake of today's lesson, we're going to plug in the following information. So the sea level temperature, we're going to say at this current place, it is 20 degrees Celsius. For the condensation point height, it's going to be 1,100 meters. For the peak height, it's going to be 2,500 meters. Now, the last 2 important pieces of information here are going to be the cooling rates. And this statistic here, you'll be able to use in any calculation that you're going to be using for the elevation calculation. And this will always remain the same. So the cooling rate up to the condensation point is going to be 1 degree Celsius for every 100 meters that you travel. And the cooling rate from the condensation point to the peak is going to be 0.6 degrees Celsius for every 100 meters you travel. Okay, so now that we have all vital 5 points of information, we can get started on today's elevation calculation. Okay, so to help understand the calculation a little bit better, what I typically like to do myself and what I encourage my students to do as well is to draw a little mountain like this. Okay, I'm going to put a little snow-capped peak on the top. What I have my students do next is to plug in the numbers that we've just used into the mountain. So the sea level temperature we said was 20 degrees Celsius. So I'm just going to write 20 degrees Celsius here at the bottom at sea level. We said that the condensation point was 1,100 meters. So I'm going to write CP in the little cloud here. And I'm going to put 1,100 meters. And then we also said the peak of the mountain was 2,500 meters. So now that I have everything in front of me visually, I can actually complete this calculation. It'll be a little bit easier for me to understand. So let's get started with the first step. Okay, so for step 1, what I'm going to do is I'm going to put 1 degree Celsius over 100 meters. And the 1 degree Celsius represents the amount of temperature that I'm going to lose, and the 100 meters represents the interval of that temperature loss. We're going to put an equal sign. We're going to put X over my condensation point height, which is 1,100 meters. So that is step 1. Now step 2, what I'm going to do is I'm going to cross multiply these numbers. 1 times 1,100 gives us 1,100 equals 100 times X, which gives us 100X. Now for step 3, I need to isolate for this x. So what I'm going to do is I'm going to divide each side by 100. And 1100 divided by 100 gives me 11. And 100 x divided by 100, the hundreds cancel each other out, which gives me x. So for step 4, what I'm going to do is I'm going to take my sea level temperature, which was 20 degrees Celsius, which is what I started with. I'm going to subtract the number that I just lost up to the condensation point, which was 11, which now gives me 9 degrees Celsius. And that is the temperature that I now have at my condensation point. Now, the reason I had you guys draw the mountain was because it makes it a little bit easier to understand visually. So just going to plug in those numbers here again, 20 degrees Celsius. The CP is 1100 meters. And the peak is 2500 meters. So that essentially means that as I travel from here to here, I've lost 9 degrees Celsius. So just a step ago, we said that when we took 20 degrees Celsius and we subtracted the 11 degrees Celsius that we've lost up to the condensation point, we've lost 9 degrees Celsius. So right now, this is where we are at our mountain. So we're at this level here at the condensation point. The next phase of the calculation will be to determine the temperature loss from the condensation point to when we get to the peak of the mountain. Okay, so for step 5, what I need to do is I need to find the difference between my peak, which was 2,500 meters, and the okay, so our next step is step 5. Just going to write that in there. Okay, so now for step 5, we need to find the difference between the peak height and the condensation point height. So when I'm finding a difference in mathematics, the operation that I'm going to use is going to be subtraction. So I'm just going to quickly write in the peak height number and the condensation point number. So we're going to take 2,500 meters and we're going to subtract 1,100 meters, which would give us 1,400 meters. Now this number is going to be very important, so I'm just going to write a little m next to that because we're going to need it when we do our cross multiplication for our next step. Okay, now for step 6. Okay, we're going to do cross multiplication again, but instead of using 1 degree Celsius, from the condensation point to the peak, the new cooling rate is going to be 0.6 degrees Celsius. So we're going to put 0.6 over 100, because that's going to be the interval of loss. And we're going to put x over our new difference here, which is 1,400 meters. And that's the distance that we have to travel to the peak. Okay, so for step 7, we're going to cross multiply. So 0.6 times 1,400. Just going to grab my calculator quickly. 0.6 times 1,400 gives us 840. Okay, and then we're going to go 100 times x, which gives us 100x. We're going to now, step 8, we're going to isolate for this x. So we're going to divide each side by 100, which gives us 8.4 degrees. So 840 over 100 gives us 8.4. And then we're going to divide 100x by 100. So both of those cross each other out. 100s gives us x. So that means that from the peak, from the condensation point to the peak, we've just lost 8.4 degrees Celsius. Now our final step, step number 9. What we're going to do is we're going to take our condensation point temperature, which was 9 degrees Celsius, and we're going to then subtract it from 8.4 degrees Celsius. So we're going to take 9 we're going to subtract 8.4 degrees, and it's going to give us 0.6. Okay, so just to go through everything again, what I've done is I've redrawn the mountain. I'll just put 2,500 meters at the top. So from the sea level to the condensation point, we traveled up 1,100 meters, which means that we lost 11 degrees Celsius, which put us at 9 degrees Celsius at the condensation point. So now from the condensation point to the peak of the mountain, we traveled 1,400 meters. That was the difference between the two. And when we did our calculation at 0.6 for every 100 meters that we traveled, we then determined that we lost 8.4 degrees Celsius, which put us at 0.6 degrees Celsius at the peak of the mountain. Okay, so that is the elevation calculation for you in a nutshell. Hopefully everybody understood it, and it does tie into the lower near water acronym under the E, and that's how it has an effect on climate. So guys, if you have any questions or you'd like me to go through possibly a new calculation, please let me know. I'm always here to help. Just leave a comment below and let me know what your question is. Okay, so thank you guys everyone for listening, and hopefully everybody enjoy the lecture.